let's get started. Thank you everyone for coming and joining us here today. We're very excited to present to you this webinar on achieving climate targets with circularity. So I'll just introduce myself before we start. My name is Michelle Gordon, and I'll be your moderator and host for today. I'm a senior consultant and product sustainability lead at Nordic Sustainability, and I will run you through our program before introducing our fantastic panelists and presenters who have joined us here today. So in today's session, first, I'll give you a brief recap from some key points of our last webinar. Some of you might be aware that this is actually the second part in our series on circularity. We started off with a webinar on those EU policy briefing on the policy area of circular economy and products. And then we have the webinar here today, and will be followed by 2 more webinars that are planned for later on in May and June on circular business models and integrating circularity into product development. So please do stay tuned to our LinkedIn for updates when we announce the dates there. We'd love to see you. So then after my recap, we will be having Maja Johannessen, who will be presenting an introduction briefly to Nordic Sustainability before giving us an overview on the business case for circularity. So Maja is a senior manager here at Nordic Sustainability, where she leads our circular economy services and projects. She has previous experience with over 4 years at the Ellen MacArthur Foundation, where she, amongst other projects, led their Policy Insights and Developments program, and has also experience at Metabolic Consulting, where she advised governments, corporates, and NGOs. Then we'll have Ole, who will be presenting circularity as a lever for decarbonization. Ole is a senior manager also here at Nordic Sustainability, where he leads our in-house climate services. He's our go-to expert on everything relating to climate change and strategy, where he works to design ambitious climate strategies, roadmaps to achieve them, greenhouse gas counting, and works on science-based target setting and net zero strategies. He has previous experience at the London-based NGO, the Climate Group, as well as the Danish innovation consultancy Leader Lab. And last but certainly not least, we have our guest star, Johan, who is joining us from Ørsted's global sustainability team, where he leads the strategic program on circularity. And he'll be introducing to us the case of Ørsted and circularity in the renewables industry. So before joining Ørsted, Johan has over 5 years of experience consulting in the Nordic buildings industry, and then has actually worked on some of the world's first and most circular demolition and construction projects. So very excited to have you here today, Johan. All right, so without any further, but before that, I also just wanted to let you know we'll be having a Q&A at the end. Some of you have already asked some questions in our Q&A panel. Please add them in there so we can keep track of them. And we'd love to have those there to ask our panelists today. So remember to keep adding in there. And you can also type in the chat if you have any comments to share with us or the group. Good. So last time we saw you all, we had a webinar on an EU policy. And specifically, there's been a lot of developments in draft policy relating to the circular economy and sustainable products that we provide an overview for you. And we'll share in the chat and over email the link to the recording. So really, there were 3 key developments that we see as important as this policy area is developing. First of all, there's a new era of transparency of sustainability reporting that is on its way, which is much more comprehensive. The requirements will be asked from companies than ever were seen before. And this will help enable transparency that will be able to help us see if companies are truly scaling their circular resource use and business models. The next, the EU is working to develop eco-design requirements for almost all product types within the EU. This will help them make them more repairable, durable, and longer lasting. And then this will help level the playing field for product design and enable companies who want to work with circular strategies implement those with this more level playing field across different companies. And then finally, we have greater requirements for for communication with a regulation that's being developed against greenwashing. So companies will no longer be able to communicate vague sustainability claims and will have to actually back up any communications about sustainability using life cycle analysis methods that are independently verified. So these three developments of greater transparency, eco-design requirements for products, and a regulation against greenwashing is creating some changes that we see that will help companies and will create an environment where companies that want to embrace circular business models can reap the rewards of doing so. So do check out our webinar after this one. Next, I'll pass you on to Maja, who will give us a brief introduction to Nordic Sustainability before jumping into the business case for circularity. And you can go ahead, yeah. Maja, when you're ready.
I couldn't find the mute button. Anyways.
Well, I can hear you now.
Thank you very much, Michelle, for this good introduction. Also, just like briefly, for those of you who don't know us, just a few words on who we are and what we do. Nordic Sustainability is a Copenhagen-based consultancy firm. We work in the intersection between strategy and sustainability. We primarily work with large corporates in North Europe, and that we run projects from everything from baselining, impact assessment to strategy development, and then of course also implementation, so delivering on those strategies as well. Then on circularity specifically, we work with businesses for a number of reasons. As Michelle just mentioned, there is a new wave of regulation coming from the EU. So of course, like the new reporting requirements include circularity aspects. There's like the new, of course, also everything related to product design, but also innovation processes is something that they work with businesses around, and how to incorporate circularity into this. And then finally, of course, also developing strategies and integrating circularity into overarching sustainability strategies. And then finally, as we're going to talk a lot more about, and Ole is going to give a good examples here on like also how helping companies reduce their CO2 emissions, and especially those in their scope 3 emissions through circularity measures. But before we dive into the practical examples, I'm just going to spend a few minutes just running through and recapping on what is the circular economy and why is it that we are interested in the circular economy from a business perspective and a climate perspective. So speaking of circular economy, it's always good to start with the challenge. And the challenge is that we have now surpassed our ecological boundaries for economic activity on a number of ecosystems. So, for example, this is also one of the reasons why we're now rapidly nearing climate collapse. And the reason for this is that we currently have a linear take, make, dispose economic model where growth relies on raw material consumption. So literally meaning we cannot grow our economy without growing our material footprint. And this is, of course, problematic because this is directly linked and drives this emission of CO2, water depletion, biodiversity loss, and so forth. So it means that in this model, we cannot really grow further because that we are limited by the planet we are inhabiting. So what we want to do is, of course, to find other ways to generate value that's aligned with our ecological systems. And thankfully, we can do that. We can redesign our economy. And also, it brings quite a lot of opportunities, not just ecological, but also economic opportunities. Because when we look at our current economic model, there's a lot of problems with it and a lot of lost opportunities. Because we have designed an economy that is literally inefficient by default. So that means, for example, for businesses right now, they benefit from a low utilization of the materials and products to put on the market because that enables them to sell more products and thereby growing. But that's, of course, that also leads to, for example, huge underutilization of assets. So, for example, we see in Europe, cars are parked 92% of the time, often taking up really valuable urban space while being parked as well. We also see that, for example, in our production system, that these are like inefficient and also costly. So, for example, every dollar spent on food, society pays $2 in societal cost. while at the same time, 1/3 of all of this valuable food is actually lost throughout the value chain without creating any value. And then linking to that, of course, is also just like a general loss of valuable materials in the economy. Here, e-waste is a really good example. E-waste represents $63 billion annually. Only 20% of those is actually captured and recycled at like a appropriate value, which means, of course, that that's problematic. Huge lost opportunity, but of course also really critical because these materials are crucial to our modern economy and also very much crucial to the green energy transition. So tapping into these losses that are in the current economy and figuring out how to capitalize on those is, of course, a massive business opportunity. And the way businesses can do that can be in many different ways. They could be through different means of productions, using recycled input. It could also be through sharing of machinery and some facilities to do it. But it could also be trying new revenue models, so going to more like service-based business models, or selling refurbished parts and so forth. And finally, there's also a big chunk of businesses, of course, don't do production but works in the enabling space, so they can help others implement circular activities. So that could be everything from design, logistics, R&D, education, consultancies, and so forth. And I mean, there's been a lot of economic analysis of the circular economy, but in 2015, McKinsey and the MacArthur Foundation valued that if Europe transitioned to a circular economy, there would be a net economic benefit of 1.8 trillion euros by 2030. So of course, this has also been a major driver to like why businesses and policymakers have been putting the circular economy on the agenda. But of course, the reason why we're here is actually not to talk about the business opportunities as such, but it's more around talking on one of the main co-benefits of the circular transition, which is, of course, the reduction of CO2 emissions. So as we just mentioned before, the circular economy is really addressing the root causes of some of the issues we have with, for example, climate change. And this is also why, for example, the EU has incorporated circular economy as one of the key pillars in the current economic development plan, the European Green Deal, where they right out also mentioned that there is like to reach net zero by 2050, Europe need to decouple from raw material consumption. Yes, but just to kind of wrap this short intro off, so we see that a lot of businesses are already working on circular economy and working on finding ways to incorporate circularity into both products and business models. And the motivation for them to do so is very much linked to economic opportunities, which in more granular terms are both linked to, for example, creating greater supply chain resilience. So becoming less reliant on new input material and new components, of course, creates greater resilience in volatile markets, as we, for example, saw during COVID. We also, of course, see that with the new diversified revenue streams, companies can grow in a less material-tense way, which, of course, enables them to be in business for longer. And then finally, all of this, of course, also helps business to become more competitive in a market that is increasingly regulated by the EU, and which also will be increasingly rewarding more sustainable business activities. Yes. So, but that was enough about the high-level picture. So now I'm just going to hand over to Ole, who's then going to dive a little bit more into the concrete ways that businesses can reduce CO2 emissions through circularity.
Thank you so much, Maja, and thank you so much, Michelle. As Michelle mentioned in the beginning, I'm leading our climate services here, so I have the fantastic opportunity to speak a little bit about like how circularity gives a lot of opportunities to reduce our greenhouse gas emissions with businesses here. And although this is not a new conversation by any means. We've actually been speaking about this for some time now. Then I would say that it is as relevant as ever to remember circularity as a key decarbonization measure here. Throughout this presentation, I'll give you some tangible examples of how that actually works in practice. So that's what I will be spending the next 10-15 minutes on. Good. So why are we talking about this? Well, right now we're seeing an absolute explosion in companies setting decarbonization targets, climate targets here. Many are using this science-based targets initiative to set these ambitious climate targets. But the whole point of this is more and more companies are setting ambitious climate targets, and we see climate change or decarbonization as a key focus area for many businesses for their sustainability focus area. So really understanding that circularity feeds into this is super important. Good. So how is circularity and decarbonization connected? Well, what we're seeing for a lot of companies right now is that they are trying to achieve their decarbonization targets through changing their energy source to renewable energy. And this is a really, really important and effective way also of decarbonizing your business. And it also makes a lot of theoretical sense. We know that roughly 75% of global greenhouse gas emissions are energy-related emissions here. But when we look into some of the scenarios that has been built for how we achieve net zero emissions by 2050, we also know that the generation of new renewable energy is unfortunately not going fast enough. We need other measures to decarbonize the world and our businesses as well. And if we look at the International Energy Agency's roadmap specifically, then they say that 2050, we're going to have an economy that's roughly twice as big, serving 2 billion extra people, and we're actually going to have to spend 8% less energy than we are today here. So energy efficiency and material efficiency are crucial elements of any sound decarbonization strategy. And here circularity is one of our most effective means to do that in the right way. Good. So taking it a little bit back to basics, I imagine that many people who joined this webinar has seen this image before. This comes from the Greenhouse Gas Protocol. And what this image shows is what a company needs to account for when they're looking into the greenhouse gas emissions. Many companies have historically looked primarily into their Scope 1 and Scope 2 emissions, that they're called operational emissions, which comes from the energy that they're buying and the fuel that is burned in company vehicles and at operations and such. Many companies have forgotten a little bit about their value chain emissions, but this is absolutely in scope of what a company should account for. And these are all things such as the emissions that come from the raw materials you buy in order to produce your products, the logistics services you buy, the waste that you produce, business travel, the energy that your products use throughout their lifetime, and the end-of-life emissions that comes from the products that you sell when they reach their end of life. So many, many different things that companies take account for. And what we also know now is that this source of emissions, the value chain emissions, typically accounts for roughly 75 to 99% of emissions for a lot of companies. Therefore, it needs to be a key focus for us to do something about it. For production companies, then the vast majority of these Scope 3 emissions comes from the raw materials that is purchased in order to produce the products that they're selling. We also know that quite a few companies, 2/3 are not currently reporting on Scope 3, and many struggle with accounting for emissions from products and services here. So there's a huge potential to do a little bit better, and we know, and if we accept that circularity is a key way of dealing with these emissions, and we need to do something about these emissions here, then it poses the question, how do we go ahead and actually do something about this? And this image here, I really like, because I think it shows the benefit of circularity in a really strong way. And although it's fantastically geeky and very difficult to see, then it shows you the vast number of processes it takes to produce one chromium steel pipe. And for those of you who's wearing very, very thick glasses, you might be able to see the numbers up on the top right screen here. But basically what it says is that what we see on the image is 94 out of the roughly 13,700 processes that goes into producing one of these steel chromium pipes. And this is, of course, so much more than we can ever deal with, so many processes here. But that's a beautiful thing about circularity, because here, instead of going in and dealing with individual processes here, we're actually cutting out a great part of these 13,700 processes here, simply by reusing materials, recycling processes, or simply cutting some of the products away, some of the raw materials away by making it a little bit smaller. There's different benefits and there's different trade-offs to the various things that we can do on circularity, also from a carbon point of view. So doing the right thing is absolutely necessary. And this is what I will cover here in the rest of the presentation. So when you want to start engaging with circularity, then there's a few things that you need to understand from the beginning. First, you need to have an understanding of your greenhouse gas emissions and the greenhouse gas emissions that are coming from the products that you're selling. So understand the impact of your products. This will allow you to identify some hotspots, which will in turn allow you to focus on the most relevant emission sources for your business. And then comes the challenging part, or the interesting part, where you then choose which circularity means or which other means that you'll use in order to decarbonize your business here. As a rule of thumb, we recommend that you use the circularity hierarchy. It tends to bring greater financial and sustainability opportunities if you start at the top and work your way down. So refuse, reduce, reuse, remanufacture, recycle. And if you remember that at the end of the webinar, then I am happy. So what I'll do here for the remainder of the webinar is take you through some tangible examples for each of these things and show you a little bit about like how this can help you do some reduce your carbon emissions, your greenhouse gas emissions. So when we are talking about refusing and reducing here, then we are simply cutting away unnecessary raw materials in order to produce our products. So if we look at this, these images down in the bottom, like this process of producing something here, we're simply cutting away kilograms or tons of the products that we are producing and cutting away quite a few of these processes here. This is a really effective means of reducing overall emissions. And generally, because you need to buy less raw materials in order to produce your products, it comes at a lower cost. It will reduce your CO2 emissions, and maybe it can even bring some innovative new designs that makes your products more useful for your customers. It can have a negative effect on product durability, and maybe some of the things that you have to cut away in order to reduce emissions here has some sort of commercial marketing effect. And of course, this needs to be taken into consideration when you're choosing which option to go with. And in order to make this really, really tangible, I would like to introduce you to the fictitious company, the good company, which sells chairs. I will use this example 4 times and to show you how this works in practice here. But in this first reduce example, then the good company has 80% of their material-related emissions coming from the materials that goes into the chair, and 20% that's coming from the packaging. The good company, though, realizes that they're using way too much packaging. It's completely unnecessary, and they can actually cut this packaging by half. So by doing some quick maths, we know that if we cut 50% away of 20% of the overall emissions, then we cut 10% of the material-related emissions by refusing and reducing packaging here. So this is example number 1. In reuse, we are talking about something that's slightly different here. Here we are talking about introducing a new way of doing things. So here it could be that a company introduces a take-back model, or a company starts renting or leasing out things instead of just selling it here. And when we are looking at the below here, at the below image again, then we are also cutting away quite significant parts of the processes that are needed in order to sell the product or rent out the product that we're renting out, simply because we are taking an old product and putting it back into the system away. We're cutting away a lot of these processes. It might result in some additional logistics because you need to go and pick up the product again in order to resell it. But generally, this will have very good effects on both CO2 and also the price of that you replace from having to buy new raw materials. And what's the case for this good company here? Again, well, the good company, they introduce a new rental model for their chairs, and they are super happy about this because it becomes a major success here. It becomes 20% of their business revenue very, very quickly. And the good thing about this renting model is that it allows them to generate the same revenue from one single chair, like 5 times more effectively as if they were selling the chairs. So that basically means for the materials that they use, they save 80% CO2 emissions because they can use the same chair to generate 5 times the revenue. I hope that this is not too unclear. I realize that I might not have explained this in the best way. Unfortunately, through additional logistics, then you do have a negative impact as well. Additional logistics can add some extra emissions. In this example here, there's 10% extra emissions coming from logistics, but it still results in an overall saving of 70%. That's example number 2. In example number 3, we go into remanufacturing here. And remanufacturing and reusing is very, very similar. But unfortunately, in the remanufacturing scenario, when you get back the product again, then it is not ready to go back on the market. There's some parts that needs to be replaced. There's some parts that needs to be repaired. But through take-back systems and the like, you can still ensure that you keep a great part of the materials used in a product in the market, avoiding you having to replace it with new materials. And that has some significant, very, very good CO2 benefits and also cost benefits because you don't need to buy new raw materials in this example here again. So what does that look like? Down in the image here, you have parts of the product where you need to buy new materials, but you have parts of the product that you can reuse the same thing here again. There might be some of your customers that tends to think that having a reused product or a remanufactured product is not as valuable because it's not new or nice in the same way, but generally it brings some very, very nice effects. For the good company, again here, they choose to introduce a take-back system here. Their customers are super happy about it because now they don't have to deal with the chairs when they reach their end of life. And they are actually able to reuse 70% of the material, the CO2, the materials relating to 70% of the CO2 of the chair. And they have to, but unfortunately, then they have to do some additional repairs to the chair that draws in a negative direction. So they have 10% additional emissions from repairs. And then again, they have some additional logistics emissions because they need to take back the chair. But overall, because they can reuse so much of the chair, they see an overall saving of 55% of the greenhouse gas emissions through this take-back system and remanufacturing here. So again, a really, really, really nice saving. In the final example, we have recycling, and recycling works quite differently from both the refuse, reuse, and the reduce and remanufacturing example, because here we're not reusing or refusing anything. Here we are simply just taking raw materials and making sure that they're not virgin raw materials, but they're recycled raw materials instead here. But this can still bring some really, really nice benefits. And as you see down in the below graph here we're not cutting away any of the overall product streams, but we are cutting away the bottom of some of the product streams. So we don't have to get the materials out of the ground, which normally results in quite a bit of CO2. We don't have to getting them transported to the first place. We are cutting away a lot of the bottom layers here, which is normally quite CO2 intensive. This can bring some good CO2 benefits, but it doesn't in all cases. And this is where it's really, really important that you take account of which sector you're in and which raw materials that you're using. For example, when it comes to chemical recycling in certain cases, then it's so energy intensive to do chemical recycling that the CO2 benefits that you see from the chemical recycling might be very, very minimal, if not actually not so good. So it's really, really important to think about which means that you're using. What does that look like for the good company? Well, the good company, they have this one product line, which is the PET chair. I realize that that is a little bit strange kind of chair, but nevertheless, the good company have a product line around this here. And they realized that from using virgin raw materials, virgin PET, they use 2.5 kilograms of CO2 per kilogram of PET that they use for their chairs. Whereas if they used recycled PET, that would be cut down to 0.8 kilograms of CO2 per kilogram of PET used here. So with some quick maths, then we quickly realize that we can actually save 68% CO2 from using recycled PET instead of virgin PET. Good. So I realize that a lot of these examples here are quite basic, and of course the real world is a little bit more complicated than for a company that just produces very, very simple chairs. But hopefully this gives you a little bit of an overview of how powerful circularity means can be to actually reduce your CO2 emissions. And I want to leave you with a few conclusions, just going back to the beginning here. If you have set an ambitious climate target, then please know that you can't get all the way there just by changing to renewable energy. That's the case for most industries, at least. Circularity is absolutely necessary. And there's many, many ways to introduce circular practices into your decarbonization efforts that brings different results. Figuring out what the right thing to do is, where you maximize benefits and reduce trade-offs, is really, really sound when you're doing your decarbonization strategy. As a rule of thumb, though, then follow the circularity hierarchy. It will tend to give you the best economic and sustainability benefits. And finally, going back to Maja's point from before here, of course, decarbonization isn't all, and one of the wonderful things about circularity is that it deals with the root causes of our products, which tends to give many, many benefits beyond decarbonization, such as water and waste and such as well. So circularity is the way to go also for decarbonization. Thank you very much.
Thank you, Ole, for that fantastic presentation and running through those examples here. Very much appreciated. And now we will pass on to Johan for our next presentation of today.
Thank you, Michelle.
And yes, here is your presentation. Go ahead.
Awesome. So this slide basically just tells that what I am going to talk about today is a little bit more practically circularity in the renewables industry, an industry that is both a key for decarbonization in itself, but also has challenges to achieve decarbonization within the industry. So it's sort of, kind of a good dilemma here, right? If you jump to the next slide, Michelle, let's start out with just presenting a little bit about who we are in Ørsted. First, you might not know us at Ørsted, or hopefully you do today, but not too long ago, we were actually called something else, DONG, Danish Oil and Natural Gas. But today we are called Ørsted, and that's mainly because we have been through a transformation of our business, going from making energy with oil and gas to actually being a leader in offshore wind energy, now also having expanded our portfolio to onshore wind, solar, hydrogen production, power to X, and so forth. We are a globally operating company with assets and operations in both APAC, Europe, and the US. And due to this transformation from oil and gas to renewable energy, we have for quite some time been recognized as a sustainability frontrunner, as some of these highly esteemed organizations such as the Corporate Knights, CDP, and so forth. Just one takeaway here, 2006 versus today, we have in fact achieved an 87% carbon footprint reduction of our own operations. So that would be the scope 1 and 2. Just remember that when we move into how circularity can then help to achieve full decarbonization of Ørsted. Next slide, please, Michelle. So at a glance, what is sustainability to Ørsted? So oddly enough, ever since we made the transition from oil and gas and fossils to renewables, our sustainability team in Ørsted has been growing excessively. So I started 2 years ago, we were 10 people. Today, I think we are 25. And one could say that when you have already achieved such a transformation and such an incredible carbon reduction in a very short time, do you then need to expand your sustainability efforts? Isn't it enough to just go from fossils to renewables? And obviously the answer here is no. We recognize that we still have quite an impact on everything we do, upstream, downstream, operational wise. And in general terms, you can categorize it into 4 sort of overall sustainability themes where we think we need to be focusing our priorities. I think we have a tagline saying something along the lines that we want to give more to nature and society than we take. We can always discuss how that actually works in practice. But among the themes here, you will see science-aligned climate target action. You will see green energy that revives nature. Then a heavy focus on also the social and societal aspect of how you operate a business. I know not so related to decarbonization, but when we talk about circularity, we should not forget some of the impacts it also has on social sustainability. And the last bucket would be around governance, enabling right decisions within the company. Michelle, you're welcome to jump to the next slide. So how does circularity then feed into our overall sustainability ambitions and priorities and programs? The difference between circularity and many of the other sustainability topics is that circularity is a lever. It's a tool, it's not an impact, right? We have carbon emissions as an impact, we have biodiversity loss as an impact, you have damages on local communities as an impact, you have human rights and labor rights violations as an impact, but you have circularity as a tool that can in fact mitigate many of these impacts. One thing in common from many of these impacts that we have identified is obviously the material use of growing the renewables sector. So I heard somebody classifying or characterizing the green transition as a move from a fossil intensive system to a very heavy material intensive system, meaning that in order to move away from burning fossils, we need to make all our turbines, our solar farms, and so forth, and those are not free. They come with an excessive use of various raw materials that we need to extract, mine, process, manufacture, and so forth, very much aligned with some of the diagrams that Maja and Ole have already shown. So we know from that material use there are various impacts, and with circularity we do want to address all of them. I'm not saying that circularity is the answer to everything, far from, but it really spans wide when we look at the positive impacts of moving from a linear to a circular resource use. Michelle, next slide, please. So to make things a little bit more tangible in terms of, okay, circularity can, in fact, do mitigate your impacts, then let's focus a little bit on our decarbonization plans. I think one of you, Ole and Maja, showed that there has been a heavy increase in companies taking climate-based or science-based climate targets. Ørsted was, I believe, the first energy company to do so, and we want to be entirely carbon neutral across our scope 1, 2, and 3 emissions by 2040. So far, so good, but there is still some way from ambitious and bold targets to actual delivering progress, delivering results, and getting over the finish line. Ole, you had a go-to guide on how to implement circularity, and I think the first thing you said was understand your emissions, where are they coming from, do a hotspot analysis, and then take a starting point in that. And we have not coordinated this presentation, but that is in fact what we have done through working with life cycle assessments, and in this case with a focus on the carbon emissions, knowing that a life cycle assessment also accounts for at least 20 different environmental parameters, right? But here we have done life cycle assessments of some of our assets. What I'm bringing today is some high-level takeaways from a wind farm, an offshore wind farm. And we see very clearly the picture that, again, I think you said it all, at least 75%, approximately 75% of our total carbon footprint of a wind farm comes from supply chain activities, scope 3 emissions, right? Especially when we look at materials such as steel, also copper, concrete, some composites, but especially steel, that basically accounts for 50% of the carbon footprint itself. We use steel in the turbines and the foundations and so forth. So a heavily material we are depending very much on to accelerate the green growth. In the operational space, which is 25, 30 years of an asset today, we see that vessel transportation, burning fuels back and forth from shore to offshore, and replacement of components are some of the biggest factors of our emissions. Then on an overall note, we also see that the lifetime of our assets very much influence how the carbon footprint of an asset looks like. And that's obviously because the longer we operate, hopefully the more energy we generate over a lifetime, and that means the energy you use to construct the farm will be much less compared to what you actually get out of the farm. If you only did operations for a year and then started decommissioning the wind farm again, you wouldn't have a very good business case, but also an extremely high carbon footprint. Last but not least, we see that decommissioning, resource recovery, and what we do with materials at their end of life also plays a role, directly and indirectly, I would say, also a little bit depending on how you do your life cycle assessment. So, having identified our hotspots and knowing a little bit about where emissions come from, what materials, what processes we should be looking into, we have tried to translate that into areas where Ørsted believes we can influence our resource use the most and do basically the biggest impact, right? And if you jump to the next and last slide, Michelle, this also looks a lot like a diagram Maja showed at the beginning of the presentation here. We have categorized our efforts in 3 strategic pillars, very much acknowledging that Ørsted is a developer and operator of renewable energy assets. We don't manufacture the components ourselves. We have original equipment manufacturers doing that. So there is always a balance between what can we do ourselves directly. If we wanted to make everything different tomorrow, could we do so? We very much depend on good strategic partnerships with our entire supply chain and value chain to do so. Yes, so with that in mind, these are the 3 strategic pillars. The first being whatever we can do when designing and also procuring and sourcing for a new wind farm. We call that narrowing our material loop, basically using less material up front. That should be an end goal, also corresponding to Ole's hierarchy of circular levers. The next is everything that happens from you construct the wind farm to you take it down, essentially, and maybe even after you take it down, which is, I've called it a late life strategy, because obviously in the early life there shouldn't be that much to do. But the older an asset gets, the higher the risk of components breaking, being damaged, and so forth. And instead of just throwing out, buying new, replacing them, the more we can actually start remanufacturing, reusing, repairing some of the major components, blades, gearboxes, cables on the seabed, the less new materials we have to put into a wind farm. Obviously cutting a lot of the production emissions from that. As I said, we also see that on a general term, the lifetime of the entire asset really plays a role. So if we could look into lifetime extension of those assets with up to 10, 15 years, the case of the carbon footprint will look vastly different. So that's something we're also looking into. Last but not least, we got the resource recovery. there is a common saying in the renewables industry that we are so circular, we don't have a problem because 90 to 95% of the material weight of a wind farm, at least, or a turbine, can be recycled at end of life. And I think maybe that says a little bit about where we are in the renewables industry, that we have actually started from the bottom. And then we are slowly trying to move a little bit up the waste / the circular hierarchy, right? Because we do know that, yes, recycling, recovering materials at their end of life does have an impact. It also enables us to take those materials and bring them back in, for example, a new wind farm, other industries as well. We are not marrying ourselves to a closed loop here, but there are certainly other things we need to look at before starting to only talk about recycling and recyclability of the wind farm. I've listed some examples on the left-hand side of how we've been going about designing and sourcing. Knowing that steel accounts for 50% of our carbon footprint, a good place to start would be looking at, can we use less steel, for example, in a foundation? That heavy monopile you sort of knock into the seabed 20, 30 meters under the seabed to make sure that your turbines will stand in place in winter weather, contains steel, and basically just steel. If we can redesign those, if we could cut, optimize the designs and so forth, we could achieve significant carbon reductions. And we have already seen that being a possibility, right? And then, of course, we can have dialogues with our suppliers and ask them, recycled content, is there a possibility for you to use scrap steel instead of virgin steel, for example? Even ask them if they could produce components with something else than steel, maybe a renewable product, wood. I've seen on onshore, you can actually get wooden towers for your turbines now, and not something produced out of steel. So still many things to explore, and many levers to know much better in the renewables industry to become truly circular. I think that's it for me. Now let's jump into the Q&A.
Whoops, flip through all the slides, but thanks so much, Johan, for that presentation. And yeah, for giving us some examples about how even an industry like in the renewables, it needs to consider circularity to achieve decarbonization, an industry that we normally think of as being very sustainable. But of course, you still have so many challenges to work with. So thank you so much for that. And I've seen so many great questions already coming in for our panelists, but do feel free to keep them coming, and we'll get to as many as we can today. One of, I think, to start off with, we've had a few people asking about the trade-offs with circularity and greenhouse gas accounting. And Johan and Ole, you've both touched upon these as well in your presentation. And specifically also, we have heard from some participants talking about the conflicts between the greenhouse gas protocol and circular implementation. There's one example that we know of sometimes prolonging lifetime of products that have high energy use can also increase their emissions in the use phase as one example. But perhaps you can speak about some other conflicts that you've seen in your experience, and then just generally the trade-offs that you see with circularity and greenhouse gas accounting. I'll pass the word on to you first, Ole, before passing that on to you, Johan.
Sure. Thanks, Michelle. Yeah, I think it's a super good question, because unfortunately, like I mentioned earlier, there are trade-offs, and I think we see it in quite a few different areas where, when it comes to a company's emissions from waste and end of life emissions, then sometimes the emission factor for recycling is higher than it is for landfilling or simply incinerating things with energy recovery. So here there's a disincentive to use recycling processes at end of life. There's also something that I can see have come up quite a bit in the questions, which is about the longevity of a product. So if a product has a longer lifetime, then it will tend to use more energy over its lifetime as well. Here's also an issue. And I think this is probably one of the ones that comes up a lot. And it's unfortunate, but I think what this issue tells us is that we need to focus really hard on the energy efficiency of the products that we're selling that is using energy throughout their lifetime. We might already be doing this, but it gives an additional incentive to really increase energy efficiency of the products that we are selling. Hopefully, by extending the lifetime, it also gives the opportunity to introduce service models for businesses like that. They can do servicing or spare parts. That means that they introduce new revenue models into their work, which might mean that if they don't just sell energy producing products, then some of the CO2 intensity of producing entirely new products will also tend to go down because you make money in different ways.
Thanks, Ole, for that summary. Johan, do you have any more to add from your experience working at Ørsted?
One comment to an even more specific question on the inevitable trade-offs here for circularity and emissions in terms of transportation, for example, of large components if you want to remanufacturing them. Circularity should inherently be a local system as well, meaning that the more localized you can do your remanufacturing and repairing of components, the less transportation really. Also having a spillover effect in terms of local green job production. We have seen some reports coming out from the UK looking a little bit into the renewables industry, and if we really optimize the remanufacturing of all those components during the operations, but also after decommissioning of our assets, we're looking into additional job creation of between 10 to 20,000 jobs locally here, right? I think that's by 2050, so I don't want to oversell it, but still it really says something about, yes, you might end up transporting it a bit. Bear in mind, we already have a very global supply chain. I doubt that you will transport a new component less than you would if you were to repair the old one. But all these spillover effects. If I can add one more comment, because there's not only a trade-off between circularity and decarbonization, there might also be cases where you, for the sake of decarbonization, want to do something circularly, but for the sake of biodiversity, for example, you actually want to leave a component where it is. Here I'm thinking about, for example, a monopile foundation underwater in an offshore wind farm where we know that staying there for 25, 35 years, there will become a sort of an ecosystem around our installations. From an extremely sort of material point of view, I would of course love to take everything back, reuse it, recycle it, whatsoever, from a very circular mindset. But how does that then correspond with local ecosystem biodiversity interest? And that's one thing we still have to figure out, I think, especially in the renewables industry, how we deal with having both climate targets and biodiversity targets at the same time.
Oh yeah, thank you, Johan, for summarizing that. And I think that touches on some of the challenges when we just focus only on carbon when we're looking at circularity, when of course it touches so many other environmental impacts as well. And it's important to have that systemic perspective. But in speaking of systemic perspectives and also understanding the bigger picture and that coming in also now even more with the new sustainability reporting requirements in the EU, Maja, we had a question about how the European sustainability reporting standards, and specifically the one about resource use and circular economy, might affect companies and their work to become more circular. Do you have any thoughts about that and the timeline in terms of how you see companies perhaps changing their processes around this?
Yes, Michelle, of course. So first of all, larger companies, the one that are listed, will now have to report much more extensively on their sustainability impacts. But then also within the next 2 years, the scope is going to increase even further. So now it's going to be any large company reporting according to the new regulation. And part of this is that companies now also have to report. There's an entire section amongst these 1,000 data points that also includes circular economy. And here companies will have to report on resource input. So what are the types of material they use? Is it recycled? How much waste is produced? How is that waste managed? Is it recycled or landfilled? companies also from resource intense industry will also have to report on the share of products by weight designed according to circular principles. So which is also, I think, for a lot of companies going to be quite a challenge. So they really have to, also a lot of companies don't even know by weight what they sell. So there's like a little bit of data challenge here. But also I think one thing that's also really important with the new reporting requirements is that companies also have to assess their business model and how it relates to their impacts. So they also have to forecast. So if you have a company have a certain growth target for the next, let's say 5 to 10 years, you would have to actually also assess what would the environmental impacts of that growth be, and would that hinder you, for example, to reach your climate targets? So if you're again a material intense company and you're intending to grow, that might hinder you in reaching your climate targets, and you would have to publicly disclose that. And you would also have to publicly disclose whether your intent in doing something about it. So I think we'll see that that's going to be quite a driver for a lot of companies to do more about the material impacts as well.
Thanks, Maja. Certainly there's a lot of developments coming out of the EU, as you just mentioned. And of course, you're welcome to catch up on that in the previous webinar. Yes, and then Johan, we had another, you just talked about trade-offs as well, but we did have a question about how in your work have you found it's possible to navigate those trade-offs? And you mentioned, I mean, for transportation, that can be relocalization. For example, repair has impacts. That's something that you talked about as well, Ole. How do you see opportunities to work and identify those trade-offs when you look and identify different solutions relating to the circular economy? So I'll start off with you, Johan.
I think, to be very honest, it will be a little bit trial and error and learning by doing, because circular economy does not exist yet, right? There's not a recipe for what is at this point the best thing to do for X and Y and Z company. I think we need to test out initiatives, ideas, assumptions on what will be the right thing to do. And then we have to review the hell out of those initiatives and figure out, did it actually hold water, right? Did it go as planned? Were there any additional energy use that we hadn't foreseen in this circular initiative? How were actually the impacts? That is a little bit my approach, and I think we shouldn't be too paralyzed, too afraid of not doing the best thing. Of course, being mindful that we don't want to greenwash anything and call it sustainable without it necessarily being so, but there needs to be a leeway for trying and failing and then doing better, obviously, and not, yeah.
Thanks, Johan. I think that's a good way to end off our session here today. We talked a lot also in preparation for this webinar that right now circular economy is still a space that is under development. It's a space where not necessarily all the answers are already there, but companies are trying many innovative solutions, innovative piloting projects, and also some companies are working on scaling them. And it's great to have opportunities to learn from one another like we are today. And I see there are so many good questions in the chat that unfortunately we have not had a chance to answer. I know some of our panelists today, I see that you're typing out some responses. But we just want to thank you so much, everyone, for joining us. And if you're welcome to also follow up and add us on LinkedIn and ask us some more questions directly. We're always happy to hear from you. And I just wanted to thank you very much for spending the time here today. And also thank you so much for our panelists, Johan, Ole, and Maja. Thank you for your presentations. And we hope to see you in our next webinar. Have a great afternoon, everyone.